Hello everyone and welcome back to Tech with NK. In this video, I'm going to propose a solution to the exercise Cs50 Pshirt from Cs50's Introduction to Programming with Python. I'm going to show you how I solve this exercise. However, I just wish you could use this to get a few tips or ideas when solving the exercise later on by yourself. So that said, let's look into the exercise and see what's expected from us. So if I scroll down to this point, we're expected to create a Python file, we call it shirt.py, and implement a program that expects exactly 2 command line arguments. So together we'll have 3 command line arguments. That will be the name of the file, our first argument, and the second argument. And in sys.argv at position 1, we expect the name in bracket or path of a JPEG or PNG file to read, and in sys.argv at position 2, that will be the second argument, we're expecting the name or the path of a JPEG or PNG file to write, that is, save as output. And the program should then overlay shirt.png. This is what shirt.png looks like. This is the image right here. So overlay shirt.png on the input after resizing and cropping the input to be the same size and saving the result as its output. So basically, we're going to run this program with 2 arguments. The first will be the path to our image, and this image we need to open it, resize it to match the size of shirt.png, and then write the new image to our second part. That will be the second argument. And to be able to effectively do this, what we need to do is to use the Python library pillow. And we'll start by opening the image with image.open, and we can look at this link to see how that works. We can resize and crop the input image with imageops.fit, looking still at this link to see how that works, and using the default values for method, bleed, and centering. Overlay the shirt with image.paste, we can still look at this link to see what that looks like, and then save the image with image.save, and we can check that out in this link. And the program is expected to exit with a sys.exit if the user does not specify exactly 2 command line arguments, if the input and output names do not end with .jpg or .jpeg or .png, case insensitively, if the input's name does not have the same extension as the output's name, or if the specified input does not exist. And each of these cases have different exit messages, and we're going to see those in the demo. And we are expected to assume that the input will be a photo of someone posing in just the right way, like in the demos, so that when they are resized and cropped, the shirt appears to fit perfectly. And here we're just told that we could create images of ourselves and overlay shirt.png on our images, just for fun, I guess. And so looking at the demo, we can see that in this first case, the code is run with 0 command line arguments. And eventually it exited with the message too few command line arguments. This second case, it was run with 1, that is full, and it exited with the message too few command line arguments. This time around, the user ran the code with 2 command line arguments, which is what we expect. However, these do not have a .jpeg, .jpg or .png extension, so we'll exit with the message invalid input. In this third case, the code is run with 3 command line arguments, and so we need to exit with the message so many command line arguments. And in this other case, the code is run with before.jpg and after.png, and it exited with the message input and output have different extensions, because we remember that our input and our output should have the same extension. And this time around, the code was run with before.jpg and after.jpg. And you see there's no output. That's because you're not really expected to see the output of this code on the command line. The code, however, saves a new image at this location after .jpg, and you can then open this to see if the code actually runs successfully. And this time around, we'll just run with a different extension, .png and after.png. And if I scroll down, we'll be able to see the demo images and what this should look like. So we have these images like the before images, and when we run the code on these images, it should look something like this. As you can see, we have shirt.png overlaid on these images. And as usual, we expected to create a directory, we call it shirt, cd into that directory and create the Python file shirt.py. And to download shirt.png and the demo images we just saw, we can run these 2 lines of code, but this will work only on Unix-like operating systems. If you're on Windows, one thing you could do is just to click on this link and the download is going to start, as you have just seen here. And we are also expected to run our code a number of times, making sure that in each case the code is able to exit with the right message or run successfully and return the right output image. So let me scroll back to the top and look at the hints that have been given to us. If I press here, we can see that we've been given a number of useful hints. The first is that we can determine a file's extension using os.path.splitttext. And we can check out how that is done using this link. And if you watched my previous videos from problem set 6, that's PyPy, Scotchify, you'll recall that we didn't use this method to be able to identify the file extensions. But this time around we'll be told to use this method and I'm going to show you how to do it. It's very easy. We recall that open can raise a file not found error if the file does not exist, and that there are a number of helpful pillow methods that we can use to solve this exercise. But the first thing we need to do is to install pillow with a pip install pillow. Also, we can open the file using image.open. This is how it's done. All you need to run is image.open and the path to the image you want to open. We can obtain the size of an image using the .size parameter, and we can overlay that image on top of another with code like this. For example, if the image we want to modify is saved in a variable called photo, what we need to run is photo.praise shirt, and the first shirt represents the image to overlay and the second shirt represents a mask indicating which pixels in photo to update. And we can open an image in VS Code running code shirt.png. So I went ahead to open some of these links to give us an idea of what we're working with. And if I go to this link, here we can see how pil.imageops.fit works. As you can see, it has a number of parameters, but we were told in the exercise not to modify method or any of these other parameters, centering, bleed, or all the rest. But the only parameters we need to modify are image and size. And this image corresponds to the image we want to resize, and this size corresponds to the new size we want to give the image. And in this other link, we can see how to run image.save to save our output image. It takes a few parameters. We have fp and we have format. fp is just a file name that's a string representing the path to the image we want to save, and format is an optional format override. And I think we were showed how to use the other functions in the exercise. So with this, I think we are good to go, and I'm just going to open up VS Code and we're going to start solving this exercise. And in VS Code, as you can see, I have already created our file shirt.py and set everything up. And like I mentioned earlier, this file shirt.py is going to look exactly like our previous files that we've been writing. That's Scotchify, PizzaPy, and the others. So if I open up these files, Scotchify.py, to give us an idea of what we're expected to do, we realize that the first thing we need to do is to import the necessary libraries. Then we need to check the number of command line arguments the user is going to run the code with. In this case, making sure that we have exactly 3 command line arguments. Also, we need to check the extension of these arguments, that's the file extension. In this case, we are not checking for a CSV file, but we will be checking for a .jpeg, .jpg, or .png. And then in try except else blocks, we are expected to open up the file. In case of any errors, catch those in an except block and exit with a message file does not exist. That's if the file does not actually exist. And in the else block, run the rest of the code. So to give us a head start, I'm going to copy all of this and paste it in our file shirt.py, and we're going to modify this progressively. However, before we go ahead and do that, I have prepared a Jupyter notebook for us to give us an idea of what we are going to do. So I'll go ahead and open up this Jupyter notebook. As you can see, I've written a few lines of code already, but that's okay. I'm going to explain all of it. So in this first code cell, I'm importing image and image ops from the library pil, or pillow if you prefer. And I'm also importing the function display from ipython.display. That is just going to help us to display images. And then I imported the module OS, which will help us to check the file paths. So if I run this code cell, that works just fine because I have all of these libraries already installed. But if you do not have Pillow installed, start by running a pip install Pillow in your terminal, and then you'll be able to run this. And in this other code cell, I opened the image shirt.png, and this is just the path to where I saved the image. And then I'm using the function display to show you the content of our variable shirt. So if I run this, as you can see, we have our shirt just like we saw online. So this tells us that our variable shirt contains an actual image. And for now, I'm just going to clear this output. And in this other code cell, I obtain the size of our image using the parameter size. And if I run this, you can see that the size of our image is 600 pixels by 600 pixels. And in this code cell, I opened a sampled image before1.jpg and saved it in the variable img, just a short for image. If I run this, nothing will happen because the image is saved in the variable img and I'm not displaying it. But then with this other code cell, I want you to see the result from split text. So if I run this, wait, let me remove this first or put it back shortly. So if I run this again, you see that running os.path.splittest on this sample path, we have a tuple that separates the path from the extension. And by using indexing, we can get the file extension, which is what matters to us. So if I run this again with the index 1, we have the file extension .jpg. And we can look at the size of this image using the .size parameter. And this tells us that the size of the image before 1.jpg is not the same size as our image shirt.png, which is why it's necessary for us to resize this image, which is what I did in this code cell, running imageObs.fade on our image using the size we got from shirt.png and not modifying any other parameters. So if I run this and I run this other code cell, we can see that our new image now has a size 600 by 600. And one thing that this tells us is that imageObs.fade returns a new image. So it does not actually modify the image before 1.png, but instead it creates a new image which are saved in the variable new_image. And in this code cell, I'm trying to modify our new image by overlaying the shirt on the image. And if I run this and run this last code cell, we can see our image with the shirt I took Cs50. So with this, I want to believe the exercise is a little bit clearer. So I'll just go back to our file shirt.py and we are going to modify this together. So as you will recall, we do need the module sys, but we do not need the module CSV. Instead, we need OS. So I'm going to import sys, I'm going to import OS, and from pil, I'm going to import image and imageObs. So these are all the necessary modules we need to solve this exercise. Then I'm going to check the number of parameters the user runs the code with. If it's less than 3, I want to return too few command line arguments. If it's greater than 3, I want to return too many command line arguments. However, I'm going to remove this because we are no longer checking for a CSV file. But the file extensions we need to check are .jpeg, .jpg, and .png. Before we do that, I'm going to create a number of variables. The first variable I'm going to call input path, and in this variable I want to save the content of sys.argv at position 1. And I'll create a second variable, I'm going to call it output path, and in this variable I want to save the content of sys.argv at position 2. And the names of these variables are self-explanatory because as you can see, they're going to contain the input path and the output path that the user is going to run with this code. And I'm going to create another variable. This one I'm going to call it extensions, and I want to use this to save the valid extensions that we are required to check. And that will be .jpg, .jpeg, I forgot the dot here, and .png. So these are the only 3 possible file extensions, .jpg, .jpeg, and .png. And next, Using the spliffx method from the module OS, I'm going to get the file extensions for the input part and the output part. I'm going to save these extensions in two new variables. The first I'm going to call input_ext for extension, and I'm going to assign this to os.path.spliffx, or pass input part as a parameter to this, and I'm going to select the result from spliffx at index 1. And I need to use one last function, that would be the function lower, or rather the method lower, so that regardless of how the user passes the extensions, that be it in uppercase or in lowercase, our code is going to convert everything into lowercase so as to make the user's input case insensitive, and then save the extension in a variable input_ext. So I'll copy this line of code and paste it here. And I'm going to modify this. This will not be input, but it's going to be output. And I'm going to remove the input from here as well, and I'll put output. So these two variables are going to contain the input extension and the output extension. And next, I'm going to use two if statements. The first to make sure that the file extension is correct, that it's either a .jpg, .jpeg, or .png. And next, I'm going to check that the file extensions match for the input and output files. So to do this, I'm going to say if input_ext is not in extensions, or output_ext not in extensions, I want to exit with the message. So sys.exit with the message invalid input. Let me correct this, invalid input. Also, if input_ext is not equal to output_ext, I want to exit with the message sys.exit with the message input and output have different extensions. I don't think this needs to be an uppercase O, so I'll just put lowercase. And so with this, we're able to check that the user runs the code with exactly two command line arguments, and that the file extensions for these command line arguments are correct and they match. Next, I'm going to modify this try block. I'm going to remove all of this. And what I want to do in this try block is to open our image using image.open. So I'm going to create a variable. I'm going to call this input image. And in this variable, I'm going to save the content of image.open input path _ path. And with this, I want you to think of input_image as the image you want to modify. For example, before1.jpg. And next, I'm going to open our Cs50 shirt. I'm going to save this in a variable or call shirt. And I'm just going to use image.open. And I'm going to pass as a parameter the location of our file shirt.png. And if for any reason one of these two lines fails, that say we're trying to open shirt.png, or we're trying to open the image that we're going to pass in the input part, we're going to catch that error in the except block, that's catching the file not found error, and we're going to exit with the message file does not exist. But if the try block runs successfully and there are no mistakes, next we're going to move to the else block, or start by removing all of this. And the first thing we need to do here is to modify our input image using imageOps.fit. And remember that imageOps returns a new image altogether. So what we can do is to modify our variable input image to contain this new image, and I'm going to run imageOps.fit with the parameters input image for the image we want to modify, and I'll set the size to shirt.size. Because we want our input image to have the same size as our shirt. And next, I'm going to overlay our shirt on our input image. And this will look like input image dot paste, and I'll give it the parameter shirt for the shirt we want to modify the image with, or rather for the image we want to overlay on our current image, and shirt for the actual pixels we want to modify. And last but not the least, I'm going to save this input image. So input image.save with the parameter output path. and this should do for our file shirt.py. So I'm going to save this or open up the terminal and we're going to test this together. First of all, I'm going to run python of shirt.py, and if I run this without any parameters, as we expected, too few command line arguments. If I run this again, let's say cat dog enter, invalid input. Why? Because cat and dog do not have the right extensions. If I run this again, cat dog house, and I press enter, we have too many command line arguments, which is just what we expected. Now this time around, I'm going to run this with correct arguments. So I'll run python shirt.py of before.jpg, and I want to save this at after.jpg. If I press enter, file does not exist. Let's see. Okay, I see why. That's because here this is not supposed to be before, but before1.jpg, and if I press enter, our file does not return anything, which I believe is a good sign. And to check that, I'm going to run code of after.jpg, and if I press enter, we can all see our output image with the shirt overlaid on it. So with this, we can all tell that our file shirt.py is okay and works just fine. If you have any questions, feel free to leave them in the comment section below and I'll be more than pleased to answer you. So that's it for this video, and if you enjoyed it, do well to hit the like and subscribe buttons, and I look forward to seeing you in my upcoming videos. That said, have a good day.